Hello, this is question number 9 from this national exam. Show that cosine x squared times sine x squared over cosine x squared plus 1 equals to 1 for all x where the expressions are defined. In part B, we want to show that square root of 2 cosine of x plus pi over 4 equals to cosine x minus sine x. Okay, part A. I start from the left hand side, and what I will do, I will take this one and multiply it here and there. Okay, so it becomes cosine x squared multiplied by sine x squared over cosine x squared plus cosine x squared multiplied by 1. But then you see that this cosine x squared and that cosine x squared are cancelled. From the first fraction, only just sine x squared is left. And the second one is cosine x squared times 1, which becomes cosine x squared. And this is the most famous trigonometric equation or identity. Sine of an angle x squared plus cosine of the same angle squared is always equal to 1. And that is equal to the right hand side. For part B, I want to use the addition formula for cosine, and my goal is to start from the left hand side again. Okay, so what I will do, we have this formula. We know that cosine of u plus v is equal to cosine u cosine v minus sine u sine v. This is the formula which is available in the formula sheet. So now what I will do, I give the role of u to x, and I give the role of v to pi over 4. Okay, so the left hand side, I have 1 square root of 2 here, so I copy and paste that square root of 2, and then I open a pair of brackets. Instead of that, I use the addition formula for cosine, so it becomes the cosine of the first one, x, times cosine of the second one, pi over 4, minus sine of the first one, x, sine of the second one, pi over 4. But hopefully you remember pi over 4, which is 45 degrees, is one of the famous angles in trigonometry, and then you know that these values are available in the table of values at the very end of the formula sheet. And here, coincidentally, both of them are the same numbers. So this number is just 1 over square root of 2, and this number is also 1 over square root of 2. Okay, so if I want to write it a little bit compactly, so it becomes square root of 2, I would write 1 over square root of 2 first, multiplied by cosine, minus I would write 1 over square root of 2 first, multiplied by sine x. And now what happens if I multiply square root of 2 here? This will cancel that one. I also have to multiply this here. This will be cancelled. And then what is left for me is just simply cosine x minus sine x. And again, it is equal to the right hand side. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.